This is part 3 in where a tangent intersects a curve at one point, and the general derivative, also called the difference quotient, that process produces the general slope equation. So I want to go through another problem with you, and this was one that we did in class where we substituted in 1 plus h and 1. This was already done in detail. And our answer, after we plugged in h is 0, was -1. Now that was the slope of the tangent line at the point x equals 1. Of course, this is a parabola that opens upward and has a y-intercept of 1. What I want to do now is do the general derivative, which uses x plus h and x, not just one point like x equals 1 above. So if we substitute this in and blob in x plus h into the 2x squared minus 5x plus 1 position, and then subtract again f of x, which is here 2x squared minus 5x plus 1, and distribute and combine like terms, we see that this reduces only to things that have h in the numerator, and all of the non-h items like negative 5x and positive 5x and negative 2x squared and positive 2x squared and positive 1 and negative 1, all added out. So now if we plug in h equals 0, we get 0 over 0. So that's indeterminate. That means it's reducible. And so what we want to do is take the common factor h out and cancel it, which leaves us 4x plus 2h minus 5. Again, we would substitute in h equals 0, which gives us 4x minus 5. This is the general slope equation, f prime x, of the equation f of x up here, which is the parabola 2x squared minus 5x plus 1. So if I want to know the slope at any point on the parabola, I can substitute in, say, x equals 3. I can plug it into the general equation here for x and get 7. So that means the slope of the tangent at x equals 3 is 7 over 1. I could do that with x equals 1. So the slope would be -1. So the slope of the tangent line at x equals -1 is -1. Now, once again, I want to go to the Desmos calculator and use the great graphing tool down here at the bottom for calculus, tangent line. And instead of using the equation that they've given, I'd like to put the one on there that we just did. So 2x squared minus 5x plus 1. And then down here on line 6, not only am I going to use these, but I'm also going to put g of a, which is actually going to give us the slope. And that's connected to this g of x formula up here, which is the derivative. The derivative is the slope. So by plugging a into this derivative function up here, we will get the slope. The slope will show right here. So check in there. So you can see as I move the a, which stands for x, let's say I move it to 1. If you look down here, my slope is -1. On the one that I just did on the previous slide, that's what we got for x equals 1. And then if I want to find the slope or illustrate it at x equals 2, roll over here to 2, it, get it on right on. There we go. The slope is 3. And if you go back to the slide, previous slide, that's what we got. So this is a great tool to visualize how slope of the tangent line goes from, well, here to the left, negative, 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 and at the bottom it's 0, and then go on around. Now it's positive, 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 all on that side. And this is a good visual for what a derivative is. So the red line is the derivative, the tangent. So to finish this out, I want to go back to the original problem. I just did, down here we did 3. The slope at 3 is 7. The slope at 1 is -1. This is the general slope equation. And of course this is using the difference quotient, the general difference quotient, to be able to find the slope. So I hope this helps you out. This is part 3, and gives you an idea of how slope is related and is the first derivative.